Hello, the goal of this video is to understand the programs which makes use of the system called fork, a program like this, written in C. Before analyzing such a program, there are at least three basic concepts you should acquire. The first one is that the system called fork creates a new process. So let's suppose that the main program is represented by this line, and then there is in the program this system called fork. Now, after this system call, there is a new process. The old one, which is the purple one, and a new one, that is the orange one, here. Okay, so you have two processes. The old one, which is the parent, and the new one, which is the child process. The second concept is the following. You should know what fork returns in some situation. So I will write here to fork returns value. Fork return values. These values could be -1, 0, or a number greater than 0. So now, let's suppose in the program we make an instruction like this. Int result equal fork. So now the question is, what is the value of this variable in the parent process and the child process? So in the parent process, here, the result will be, if I make an instruction like cout result, the value will be a number greater than 0 in the parent process. So in the parent process, it will be a number greater than 0. Actually, this number is the child of the PID of the child process. For what concerns the child process, the result copy past doesn't work past. Okay, the result will be a number. It will be equal to 0. Now there is another case, last case, when you get an error, when the operating system is not able to create a new process, you have, in case of error, the result will be equal to -1. So now, for what regards the last point, in general, it's impossible to predict the process execution order. So, in general, it is impossible to predict the process execution order. Let's suppose, in this case, we have two processes, the parent and the child process. And let's suppose we have just one CPU with one core. One CPU with one core. And Let's suppose that this is the line of the time. Okay, and then let's suppose that rectangle represents the process. This the parent process, and orange one the child process. So as I said, it's impossible to say which process will be executed first. So you can have this equation or this equation, or if the turnaround time, so if the turnaround time is greater than the time slice, you can get also another situation which is represented by this diagram, this chart. Just a moment. Oops. Let's suppose the turnaround time is greater than the time slice. You can have also this situation, for example, 1, 2, and 1. But as I said, it's impossible in general to predict the process execution order unless you use the system call wait. So we should write here wait system. In fact, if you use the wait system call wait, the wait system call suspends the execution of the calling process until its children do not terminate. Its children do not terminate. This is the time. Time. Now, let's try to analyze a program. Thanks to this concept, we can analyze a program written in C which makes use of the system call fork, like this one. Just a moment. Okay. So now the question is, what is the possible output, or what are the possible outputs of this program? So now let's suppose this is the main program. This line represents the main program. At line number 7 there is a fork, but pay attention because this fork is never executed. Why? Because there is the AND operator and the first condition is false, it's 0, false. So it means that the outcome is false, no matter if the second condition is false or true. So this fork is never executed. So the program continues and goes to the line 9. Here there is a fork greater than 0. So the fork will be executed. So starting from this point, from the line 9, you will have two processes. So let's represent this fork with a star. So starting from the line 9, you have two processes. The old one, the parent process, and the new one, new one, okay, which will be green. Sorry. And this is the old one, which is orange. Now the question is, this B is printed out from the parent or the child, since this condition is true in the parent process, as we can see. So the parent process will print B. So here we can say B. The child process instead will print C. Then for what regards the child process, it will be exit, and then exit. So this is the execution of the child process. So the child process here, it starts from the line 9, it jumps to the line 11, it prints C and then exit. The parent process is prints B and then it will be print D and then will be exit also. So parent process will be B, then print out D. And then exit. So now, what are the possible outputs? Possible outputs will be, for sure, will be BDC, it's a possible output, or CBD or BCD. These are all possible outputs. Why we have different outputs? Just because it's impossible, as we said in general, it's impossible to predict the process execution order. Okay, so for this reason we have three possible outputs: BDC, CBD and BCD. We can verify this by running this code. Load. I will copy this code, which is the same in our example, and then I will copy here. I will compile, and then I will execute this code. As you can see, the output, one possible output is BDC, and BDC was among our output, BDC. Okay, thank you for watching this video and bye.